In this lecture, we're going to have our very first peek into the coroutine infrastructure that C++20 provides to be able to use coroutine types. And we have code like this that is using the co-yield operator. And when we set up a function like this, we want it to pause the moment we try to call it in our C++ program. So it is going to pause for the first time and start here. This is the default behavior you get in most coroutine types. And when you resume it, it is going to run up until the first co-yield statement, and it is going to return a 10. When we do that, the state of our function here is going to be stored somewhere on the heap again. So we're going to store the parameters, the local variables, and we're going to store the resumption point from which we will know where to resume our function if it is resumed. And another piece of information again is going to be the coroutine handle that we're going to be using to resume execution. Don't forget this. And this is going to be our program. When we co-yield, we're going to return the 10 here, and we will be able to use this in our C++ program. And the state of this function is going to be stored somewhere on the heap. We can then use our coroutine handle to resume. If we do that, we will be resuming after this co-yield statement. So we will run and print this information here and hit the second co-yield statement. This is going to post execution again, store information on the heap about this function, and return a 20 that we can use in our C++ program. We can then use our handle again to resume execution. If we do that, we will run from this statement here and run until we hit the third co-yield statement, which is going to post execution, store information on the heap, and return a 30 that we can use in our C++ program. Next time we resume, we're going to start from this point here, and our program is going to run to completion. So if we try to resume again, this is going to be a recipe for disaster because we are trying to resume a coroutine that has already run to completion. Now, we have looked at this code a couple of times now, but we can't run this as of yet. And the reason we can't do that is because we don't have this generator thing here implemented in our C++ program. And this thing we return from a coroutine is going to be our coroutine type, and it is what we need to build for code here to run. Now, there are some rules in place you need to follow to set up something like this in C++20, and I am going to break them into little pieces so that you really understand this without getting confused. And what we will do is build on top of the coroutine infrastructure to build our own coroutine type that we can use in our user code in C++ and set up something like this to use coroutines and see them run in our C++ programs. So to set up a coroutine, you need to have at least 3 things. You need what we call a promise type, you need a coroutine handle, and you need an awaiter that you're going to use to say that you want to pause or keep running in your coroutine. I realize some of this might be in the blue right now, but we are going to break this into little pieces. Now, if you're trying to set up a coroutine type, you're going to have code like this. And this is going to be a struct or a class. You can do whatever you want. If you set up this as a struct, everything is going to be public by default. So we are going to use a struct here because it's going to make things really simple. So the moment we set up something like this, we're going to name this coro type, and this is going to be our coroutine type. So this is going to be something we return from a function, and it will allow us to set up code like this. This is going to be our coroutine, and this coroutine is going to return our coroutine type here. This is something I want you to understand because this confuses a lot of people. Okay, so we have our struct, which is called our coro type, and this is going to be our coroutine type. And one of the requirements to set up a coroutine type in C++20 is to have a nested class that is exactly called promise type, as we see here. Now, this class needs to have a bunch of member functions. One of those is going to be getReturnObject, which is going to return our coroutine type. You see that it is returning coro type here, and it is taking a promise type as a parameter to the constructor. You see a constructor here that takes a promise type, so this is what we can use here. But we have a bunch of other methods in our promise type. And you need to remember these methods because if you don't have them in, your code is not going to compile, or even if you get it to compile, it is not going to work if you try to use the co-await, co-return, and co-yield operators, because these member functions are needed for these operators to work. Now, the initial suspend method is going to decide whether we want our coroutine to suspend the first time we call it, and the final suspend method is going to decide whether we want to destroy our coroutine state at the end. Don't worry about this as of yet if this is not making sense. I will show you what I mean with these methods here when we get to run code in the next lecture. We also have an unhandled exception method, which is going to rethrow exceptions we throw in our coroutine and make them visible to whoever called our coroutine, mainly from our main function, because that's where we're going to be calling our coroutine here. If you have these member functions n, your class here is going to be an official coroutine you can use with the co-await operator, for example. Take a moment to make this sink in. A coroutine has some rules it has to follow. The name of the class here is going to be our coroutine type, and for this to be a proper coroutine in C++20, we need to have a nested class which is named promise type, and this class needs to have a bunch of members implemented. Some of these members are going to allow us to support the coroutine operators we have seen. Those are co-yield, co-return, and co-await. But what we have here is the basic requirement to make our code compile. So if you have the getReturn object member and the initial suspend and final suspend and unhandled exception here, your code is going to compile and it will be able to use the co-await operator to pause and resume, and we will have a chance to play with this in the next lecture. In this one, I just want you to know these requirements we have to set up a proper coroutine type. Another thing I haven't told you about is the member variable we have here, which is our coroutine handle. So this is how you set it up. You say std coroutine handle, you pass a promise type inside, and then you set up a variable of this handle. And this is going to be what you use to resume execution for your coroutine. Remember, if we pause our coroutine, the function state is going to be stored somewhere on the heap. And the information we have in this coroutine state is going to be the parameters to the coroutine, the local variables, and all kinds of crazy things we need in this state. But another piece of information which is really important is the resumption point from which our coroutine is going to resume and keep running and do whatever it is we do in our coroutine here. So the m handle member variable here is going to be our handle that we can use to resume our coroutine if we happen to need that in our C++ program. This is something I want you to know. So once you have a promise type nested in and you have your coroutine handle, everything is going to be in place. And another thing I think I should show you now is that we are trying to deduce the coroutine handle information from a promise type we have in our constructor. And this is a syntax we have in C++20 we can use to deduce a coroutine handle from a promise type. You say std coroutine handle, you pass promise type here, and you say we want to get a coroutine handle from a promise by using this function here. And if you do that, we need to pass a promise type as is. You see that we are dereferencing this pointer to a promise type that we have here. Once we set up things like this, our code is going to work. And once we destroy our coroutine type, we will also need to destroy coroutine state information we have on the heap. And we do that by calling the destroy method on our coroutine handle. This is something you should know. If you don't do this, you're going to leak this memory, and that's going to be really bad. You don't want to do something like this. Okay, so by now we have seen about the promise type and we have seen the coroutine handle. Some of you are asking, what is this awaiter thing? Well, this is what you await on. For example, something that can be a co-await operator operand. For example, if we look at our coroutine function here, which is going to be called do work, we see that if we call co-await, we are passing an operand to this co-await operator here. And this operand needs to be an awaiter type. For something to be a proper awaiter type in C++, it has to implement a few methods. And here are the methods you need to implement. You need to implement the await ready method. You need to implement the await suspend method, and you need to implement the await resume method. Now, these are awaitables that we have in the C++ standard library. This is a suspend never awaitable. That is going to say that you don't want to suspend. And we have another one which says suspend always. And you're going to use this if you want to suspend in your C++ program. So if you want to co-await and suspend, you will pass suspend always as an operand to the co-await operator. And this is an example again of this right here. We are saying co-await and we are passing an object of suspend always. So this is going to suspend because suspend always says that we want to suspend. But if you want to co-await and not suspend, and you might need to do that depending on what you want to do in your C++ program, you can use the suspend never awaitable, and this is going to call the co-await operator, and you are not going to suspend. Now let's look at these methods in a little bit detail. The await ready method is going to say whether the co-await expression suspends, and if you return a false from this method, then the await suspend method is going to be called, and in most cases it is going to suspend execution. The await suspend method is going to be called as a result of your co-await operator, and in this method you will have the ability to suspend your coroutine or schedule for the coroutine state to be destroyed if you want to do that. The await resume method is going to be used if you have a value you want to return as a result of your co-await operator, but I am not going to show you how to do that, but this is a good place to put your return value if what you are awaiting on happens to return a value. And I have mentioned a good example of networking code. For example, if you are awaiting on a download from the internet to do something, if you get the data, you can put your return value in the awaitable. That is your operand of the co-await operator, and the value is going to be available to whoever co-awaited on your networking call function. Hopefully this is making any sense, but I am trying to make these things really easy to understand. Now, an awaitable is something that can be an operand of a co-await operator, but awaitables are also good return types. For example, in initial suspend and final suspend in our coroutine type, if you return suspend always, you will be saying that you want the coroutine to be paused on the first call. If you return suspend never, you will be saying that you don't want the coroutine to pause on the first call, and the compiler is going to respect what you specify in here. Final suspend is a little bit harder to understand, so I won't really talk about this here. If you want, I will set up another lecture later to really explain this, but I don't want to confuse you as of now because coroutines have a lot of things that can confuse a lot of people. Now, I have said that for something to be an awaitable, you need to implement all these methods here, but we can also set up an awaitable by implementing the co-await operator in our own class. Here is a simple class that is using the struct keyword here, and you see that we are implementing the co-await operator. This is how you can do this. And you can see that in this operator, we are returning awaitables we already know from the C++ standard library. So if you need to do something in your code, for example, this awaitable is going to do something else you need, you can set up code like this, and you can use this awaitable as an operand to the co-await operator, and everything is going to fall in place and work. Okay, so this is what we saw. We have the ability to set up our own awaitables, and this is going to be done by overloading the co-await operator, and you will have the ability to use this as an operand to the co-await operator, and this is going to work. Okay, so by now you probably have a good idea of the building components we need to set up a coroutine type. A promise type is going to be a class that is going to have a nested class called promise type, and this class is going to have a bunch of methods. We have seen the minimum here, but we have many more that we can set up. As we see in this list here, we can set up return value, which is going to be used by the co-return operator. We can set up return void, which is going to be used by the co-return operator without an operand. We can also set up a yield value method, which is going to enable the co-yield operator. And if we call the co-yield operator, the yield value method from our promise type is going to be called. And if this is not making any sense, bear with me. I am going to do a bunch of examples. We're going to see code running, and hopefully you're going to understand how all this comes together. Now, once we have all these pieces in place, we will be able to set up our own coroutine type, and we will be able to use it with our co-await operator, and everything is going to work. Now that you know all these little pieces you need to put together for coroutines to work, please remember that C++20 doesn't provide actual usable coroutine types like the coroutine type we just built. It provides a low-level infrastructure we can use to build those coroutine types. And this infrastructure is the rules we just learned about. For example, we need to set up a promise type that is going to implement a bunch of methods. If you break those rules, your coroutine types are not going to work. You need to be aware of this. Now, building your own coroutine types is really involved. I have shown you a little simple example, but if you do a more complicated coroutine type, you are probably going to run into trouble. This is something you should do if you really know what you are doing. In most cases, most people are going to use coroutine types that have been built by other people. In C++20, we will have actual coroutine types we can use, like corotype. So if you want to use them right now, a good option is to use third-party libraries like CppCoro and a few others, and that's going to give you the ability to use coroutines without actually going to go and mess with the coroutine infrastructure that we just learned about here. But I had to show you this because this is going to give you a good understanding of coroutines, and my hope is that it could even serve as a base to do more research if you want to do more complex coroutine types, or if you don't find a coroutine type that suits your need in what we have available, for example, in third-party coroutine libraries. Now, we have set up corotype here, and we haven't really run it. Let's head over to the next lecture and actually set up our very first coroutine type and see it running in Visual Studio Code. Go ahead and finish up here and meet me there.